Guys, welcome back to Chemicals TV. So in this video, we are going to continue our video on inductive effect, and this will be the second video on inductive effect. And we're going to cover the application of inductive effect. How do you apply inductive effect? In our first video, I've talked about the concept of inductive effect, the introduction aspect of the inductive effect. I gave what the definition, then I gave what the two types of inductive effect, which are what the plus I effect and minus I effect. Then we look at some key questions that will enable you to understand what's called inductive effect. So if you have not checked out that video, it will be at the description below, or you see it by the end of this video. It's very important you check out that video because it's actually what help you to understand the concept of what inductive effects and those definitions. So how do you apply inductive effects? Now you can inductive effects is used to predict the strength of acid and strength of base. With the what concept of inductive effects, when two acid or two base are given to you, or set of acid or base are given to you, I say sure rank them in what in increasing order or decreasing order of what acidity or basicity. Now inductive effect will enable you to what predict the strength of the acid and what and base. So we have called the strength of acid and strength of base. But in this video, I don't want this video to be too lengthy, and I want to solve many examples so that by the time you finish watching this video, you will understand how to apply inductive effect when it comes to what strength of what acid. So we are going to focus on strength of acid in this video today. In my next video, we are going to look at what strength of base. Now the main reason why I'm doing this one here is so that the video will not be too lengthy, and you once finish the video, you know that you are done with strength of acid. So by the time you see any question when it comes to what predict what the strength of acid, you should be able to do that. Do you understand? So make sure you stick to the end of this video. And by the course of this video, I'll be giving you some questions you are to do. So it's very, very important you follow through. So how do you apply inductive effect when it comes to strength of acid? There are some therefore we have what we call the acid theories. We have what we call the Arrhenius theory. We have what we call the Boswellic theory, and we have what we call Lewis theory. Now when it comes to acid, you have to use the Boswellic concept or Boswellic what concept. And in Boswellic concept, an acid donates a proton while a base accepts a proton. So any substance or molecule or compound that will donate a proton or that will lose a proton is called what acid. While any substance or any compound that will accept a proton is called base. Can either be compound, molecule, or what ion. For example, here we have HCl, hydrochloric acid. Now, when hydrochloric acid reacts with ammonia, NH3. Now, here is what acid, and here is what is the base. Follow me closely. An acid donates what a proton. An acid donates a proton, while a base accepts the proton. So, if a base accepts this proton here. If a base accepts this proton here, like if this base accepts this proton, so proton is also the same thing as hydrogen. Do you get that? So if this guy donates a proton to this other one here, how many hydrogen do you have here? 3 hydrogen. So if one should come here, it's now going to be what? NH4 plus. Do you get that? There is one I've called plus what? Cl what minus. Now what I want you to understand is that whenever a base accepts a proton from the acid, it forms what? A conjugate acid. So this is going to be conjugate acid. Conjugate what? Acid. Now, whenever an acid donates a proton, it forms what? A conjugate base. Do you understand? So, in the sense that what makes an acid an acid, it is the ability to donate a proton. Do you get that? So when you compare two acids together, now when you're comparing the strength of two acids, now one is stronger than the other one due to what? Its ability to give out a proton or hydrogen faster. Do you get that? If I should compare acid A and acid B, now what makes acid A to be stronger than acid B is because of what? Its availability, or the easier or the fast, how easy acid A can donate a proton than acid B. Do you get that? So it means what makes an acid an acid, it is the ability to give out a proton. Do you understand? So let me write this place out. I want you to understand is that any factor that will influences the giving out of what of a proton, we favor what acidity. Now let me say it again. Any factor that will influences the giving out of what of proton, what favor what acidity, or any factor that will encourages what the giving out of a proton, what favor what acidity. And in our last video we have talked about the plus I effect and minus I effect. So you can use what inductive effect to detect which acid is what is stronger and which one is what is lower. Because we are using inductive effect to predict the strength of acid. Now let's look at what the two types of inductive effects again. So here we have plus I effect. Plus I effect means what positive inductive effects. Do you get? So these are group of atoms that what increases electron density. Now that is the increasing electron density in a molecule. So called that's called electron donating. Electron donating. Okay. So when I see plus I group, they are called electron donating. An example is what is example is the alkyl group. Do that. Here we have this one here. So in the sense that examples are what are the alkyl group. Alkyl group are what plus I effect. That is, they increase electron density in a molecule. We have what we call the power of plus I effect. Do you get that? I've done it in my previous video, so you can check it out. Then we also have what we call minus I effect. Minus I effect are called electron withdrawing group. Electron withdrawing withdrawing group. So here you can see group here. Do you get that? Examples are what halogens. Do you get that? Example of what are the halogens. So these two things here, one will favor acidity, one will not favor acidity. Do you get that? One will favor acidity. Now because minus I effect is called electron withdrawing group. That they decrease electron density in a molecule. Now what happen here? Now the hydrogen will lose. Now it will make the what acid to lose hydrogen. Now because you withdraw electron, now what happen? That acid easily what lose what hydrogen. Now let me give you for example here. Let me give you an example here. If for example here we have CH3 and here we have it's okay. Now this one is just like now this one want to what give out this proton here. Do you get? So in the sense that the group that is attached now the group that is attached to this ethanoic acid matters a lot. It will affect the acidity. Is that what decrease it or what increase it? Look at something here. If for example here I have a chlorine atom is called electron withdrawing group. So what happen here? Chlorine will pull electron from carbon. Do you get that? Now because chlorine will pull electron from carbon, what happen here? Now it's going to affect this one here. It's going to what? This one. Now this carbon here will easily what lose this what hydrogen. Do that. It means that minus I effect group now favor what the loss of what hydrogen by withdrawing electron from the what molecule by what withdrawing electron from the what molecule. So but plus I effect increase the electron density. So what you want to put in your mind is that minus I effect is what is the withdrawing group. So they favor what the losing of what of proton or hydrogen. Now the more the minus I effect group, now the easier the acid can what lose or donate what hydrogen. Now but on the other hand, plus I effect is called electron donating group. Now they do not withdraw electron, rather they will push electron. There is an increase in the electron density. Now because plus I effect increase electron density, the hydrogen is not what easily what lose. Do that. So this one favor what the holding of the electron of what of the proton. This guy favor what? This guy favor the holding of the proton. Why this one what favor what the losing of what of the proton. So remember I told you that any species or group that will favor what the losing of what proton will favor what acidity. Do that. It means that minus I effect favors what acidity. Why? Because they withdraw electron from the molecule. Now the more they withdraw electron from the molecule, the easier the molecule what loses what hydrogen, the stronger what the acid strength. Minus I effect increasing what the acid strength in a molecule. Plus high effect decreases acidity in a molecule. Do you get that? And we have what the various type of what minus high effect and what plus high effect. You shake them on the board, they are displayed on the screen here, so you can copy that thing out so that you can what understand them as you what move on. So with this understanding now, let's look at some questions we see in the exam. So if you have something like this, CH3, C, here we have CH2Cl. Now let's compare the strength of both acids. Let's compare what the strength of what both acids. Now when you look at this one, you look at acid A. Now they both have the same functional group, right? The same functional group here. And 2 carbon. Now, here, this is functional, which is functional. Here we have the single carbon. This one is carrying a chlorine what atom. And chlorine atom is what? Is minus high effect group. Minus high effect group. So it means that chlorine will withdraw electrons. It's called electron withdrawing group. So you want to withdraw. So because we have chlorine here, and here we don't have anything here. We have hydrogen. Do that. The presence of what chlorine will make some more acidic than this other one here. Here we have 2 chloroethanoic what acid, and here we have what ethanoic what acid. Do you get? So the presence of chlorine here has made what 2 chloroethanoic acid more acidic than this other one here. Do you understand? So when you're comparing the strength of the acid, now therefore look at what the group that is directly what attached to it. So that will tell you if one is higher than the other one. Do you understand? It means that this guy is less than this. Or you can say, now let's say acid A and what acid what B, right? It means that B is higher than what A, that is stronger. You get? B is what is stronger. So you really want to pay close attention to this one here. Now let's look at another one. Let's look at what this question here. This is a typical exam question. Say, arrange the following in increasing order of what? Acidity. So here we have butanic acid, here we have 2-chlorobutanic acid, here we have 2,2-dichlorobutanic acid, and here we have 3-chlorobutanic acid. So now let me explain what is called increase, because so many students have issues understanding or knowing how to differentiate between increasing or decreasing. So before I answer this question here, let me explain what we call increasing or decreasing. So please follow me closely. Now when you talk about increasing, the easiest way you can notice in here is going to say 1, 2, 3, 4, and what 5. As you move from here to this point here, what are you doing here? You are from lowest to the what highest, lowest to the what highest. So if you move from 1, 2, 3, 4, 5, it's called increasing order. Increasing what order? Do you get that? Increasing order. And you know that 1 is less than what 2, right? 2 is less than what 3, and 3 is less than what 4, and 4 is less than what 5. So when we talk about increasing order, we're talking about what lowest towards highest. And what are you using is what less than. Do you understand? So you need to put this in your notes so that you understand this here. Increasing order from lowest to what highest. So when we talk about 5, 4, 3, 2, 1. So as we move from 5 to 4, is it increasing or decreasing? Of course, it's decreasing. So this is called decreasing what order? Decreasing order. Do you understand? So 5 is greater than what 4, and 4 is greater than what 3, 3 is greater than what 2, 2 is greater than what 1. So you need to understand this in here. So now say increasing order, increasing what order? That's we have to look from the lowest to the highest. So I want to take it down. I want to wipe it out. So now, how do we answer this question? You say, first of all, you need to draw the structure of all this acid here. Here we have butanic acid, that is 4 acids. 4 carbon, so it's going to be CH3, CH2, CH2, C. It's called butanoic what acid. It's what butanoic. Did you understand? Now, here we have 2 chlorobutanoic acid. It's still butanoic acid, 4 carbon atom here, but chlorine is a carbon by what? 2. So it's going to be CH3, CH2. Here we have CH. Here we have what? Cl. Here we have this one here. Do you understand? Which was 2 chlorobutanoic acid. Here we have 2,2-dichlorobutanoic acid. That is, I come about 2. I have a 2 chloro group. So let me CH3, CH2, C, Cl, Cl. You get? Then we have 3 chlorobutanoic acid. That is, I come about 3. I have what? So let me write here. CH2, C. So I'm going to write this place out. Remember, is what is increasing order. Increasing order. From the lowest to the what? From the lowest to the highest. Now, let me explain stuff well for you. Now, you start, yes, butanic acid. Now, it does not have any plus, any what minus I effect. It does not have any what minus I effect. Of course, it's going to be what the weakest acid. You get? So, any acid that does not have minus I effect group attached to it is going to be what the weakest acid. You understand? So, this one is what is the lowest. Do you understand? So butanic acid is the lowest among us all. The reason because it does not have any minus I effect, but the rest ones have what minus I effect. Do you understand? So remember we are saying increasing. We are saying from what lowest to the highest. It means that butanic acid, butanic what acid is less. Now let's look at the other one here. You check this geometry, they are having something here. They are having a chloro group here. Do you get that? And the numbers of chlorine or yeah, the numbers of what the minus I effect attached to the compound matters what a lot. Now remember here we have carbon 1. This chlorine is a carbon what 2. Right there. This chlorine is a carbon 2. This here we have 2 chlorine at carbon 2 also. Just and why we have one is carbon what 3. Do you get that? So instead that now the closer the chlorine or the minus I effect is functional group, the easier it what loses what hydrogen. Now let me say that again. You have to write it down. Now the closer the minus I effect to the what to the functional group, the easier it can what lose what hydrogen. The further away, the lesser it what lose what the hydrogen. So the position because these two are 1 1, right? So this one is our position 2 is very close to the carbon to carry what the hydrogen. Why is what is position 3? Just is far away from the carbon atom that is carrying what the functional group here. It means that this one will be higher than this other one here. Do you know the reason why? Because yeah, the chlorine is our position 2. Idea is adjacent or is the next carbon that is carrying to the carbon atom that is carrying what OH. Now because the position of this chlorine is closer to what to this carbon atom here, it can easily what lose hydrogen compared to this other one here. That makes sense here. So now when you compare these two here, you check what their position. One is what is position 2, one is what position 3. Now the one that have the minus effect closer to the what to the carbon atom kind of functional group, we what we increase what when it comes to acid strength. So the position matters a lot because this here is position 2, and here position 3. This is higher than this other one here. That makes sense here. Now, but when you check this one is having 2 chlorine at carbon 2. Of course, it's going to be higher than this one here because it's just 1, so it's just 2. Because the strength at which they want to withdraw electron is not higher than this one here. It means that after butanic acid, the next one, remember I told you that butanic acid is the lowest acid, right? The next one is going to be what? 3 butanic what acid? 3 butanic acid. So it will be 3 chlorobutanic acid, right? Then less than here we have what 2 chlorobutanic acid. The last one is what? So call this space here. Here we have 2,2-dichlorobutanoic acid. This is that. So from the lowest to the what? Highest. That's why I say what? Increasing. Hope you understand. So you can see how it is. So you use what the strain of you use what the minus I effect and plus I effect to what determine the what which acid is stronger than the other one. Let's look at what the next question. So let's look at what the second question say. Arrange the following compounds in increasing order of what acidity. Here we have various compounds here. Now before we can start answering this question, first of all, let's draw the structure of what of each of the compounds so that what you understand how to rank there and how the what structure look like. So if you look at this one here, this one is simplest form of what of ethanic of what carboxylic acid is having an hydrogen. The what you get there is this carbonatom here is the what function carry only what hydrogen. You get then this one here we have the carboxylic acid functional which is right. Then it's carrying what a carbonatom. There's that what an hydrogen, right? Then this carbonatom is carrying what two methyl group. This is that. So this for this one here. Then this one here, this carbonatom is carrying what three methyl groups. So you have CH2, right? You have this is that. Then this one here we have CH3. Here we have. So now when a person is speaking to you like this, as a chemistry student, you must know how to what draw the what the full display formula or structure. That is when you can what know how to rank them. So I want this place out. So how do you start answering it? Now they all have the same functional group. Can we ask the word functional group here? Right? The group attached to the carbonatom or the functional group matters a lot. Look at when checkmate very well, here we have hydrogen as attached. Here we have this one attached, and here we have this one attached, and here we have this. You get it? So you can see that when you check it very well, these alkyl groups are plus I effects. Remember I told you that plus I effect do not favor what acidity. Now minus I effect favor acidity, and I say that the more the minus I effect, the stronger the acid strength. But this is not minus I effect, this is called plus I effect. Do you get that? So plus I effect decreases what acidity. As a matter of fact, the more the plus I effect, the lesser the acid strength. So hydrogen is the least, like is the least when it comes to what plus I effects. Now let's look at what this carbon here. Now if you check this one, this and this. Now this one have what a carbon that is having this metal attached to it, right? And here we have this carbon that is having three what metal attached to it. Here we have this carbon that is having what two metal attached to it. So what we want to understand that the more the carbon, the higher what the plus R effects. So the more the carbon, the more the carbon, the more the plus I what effects. And the more the plus I effect, the lesser what the acid strength. So this one is having this carbon to carry what three carbons. So there's more carbon here compared to this. Do you get that? So this one is higher in what? This one is higher in what plus I what effect because it's having what more carbon. As a matter of fact, this one is what tertiary what alkyl. This is what secondary alkyl. This is what primary what alkyl. Do you get that? The higher the alkyl, the what the higher what the plus I effect, the lesser what the acid strength. Don't forget that plus I effect do not favor acidity. It decreases what acidity. So if I ask you now which one is the stronger acid, what are you going to say here? The stronger acid is this one here. Do you get? Because it's not carrying any what plus I field group. Do you get? Follow to this order one here, then this. Then it says you arrange what in increasing order of acidity, increasing order of acidity. Now we talk about the increasing order of acidity. You're talking about for the what? Increasing order of acidity. You're talking about for the what lowest to the what highest. So this one is the one that is the lowest. Do you get? Because it's the one that is carry what more alkyl group. Follow to this one here. Follow to this one. This one is the highest acid. So if you want to arrange it here, here you have CH3, three. Here you have COOH. Do you get? It's less. Do you get? So if you are moving from lowest to the highest, you use what decreasing now. You use the sign less than. The next one is this one here. So you have CH3 2 CHCOO H. The next one is this guy here. You have CH3 CH2 COO H. Then the last one here have H COO H. So you're going to do what? Increasing what? Increasing order of what? Acidity. So that is so when you are what comparing acids, therefore you need to check the group that is attached. Is it plus I effect or minus I effect? So from there you now know how to what rounding, whether increasing or what decreasing. So that is it for this question. Left to the next question. So let's look at this question. Say arrange the following compound in order of what decreasing acidity. Here we have phenol, here we have 2-nitrophenol, here we have 3-nitrophenol, and here we have 2,4,6 nitrophenol. So how do you solve this, or how do you answer this question? That like what I've told you before, you must first for draw the structure. You must draw the structure, right? So you understand how they are arranged. So phenol is like this: a benzene with what? OH what group. This is called phenol. Right here. It's called hydroxide benzene. Then we have 2-nitrophenol. Say 2-nitrophenol is this. Is what is this? 2-nitrophenol. Then you have 3-nitrophenol. Then we have 3-nitrophenol. 3-nitrophenol. Then you have 2,4,6 nitrophenol. It's okay. So that then I say you should arrange it in what in decreasing order. In decreasing order. So why this is out? In what? In decreasing order. That is from highest to the what lowest. Highest to the what lowest. When you talk about decreasing order, that is I start from the highest, go to what to the lowest. Now, here they all have the same stuff here. Shake where they have the same. The only difference is that is the nitro that is attached to it. Do you get? So nitro is the plus I effect or minus I effect. NO2 group is what is minus I effect. Is what minus I effect. Minus I effect. Do you get? And I tell you that minus I effect favors what acidity. As a matter of fact, the more the minus I effect, the stronger what the acid strength. I get. And the closer the what minus I effect to the functional group, the what higher what the acid strength. So as a matter of fact, phenol is not having any. Do you get? It's not having any. And so it's going to be what the least acid because it's not having any minus I effect attached to it. So they're going to be the least acid. Now they're going to be the strongest acid because it's having three of the nitro attached to it. So it's going to be the strongest. Now when you convert this one here and when you convert this one here, this one is 3-nitrophenol. You get. So remember, the position 2 is clear to what the position comment of position 3. So you only go to add that so that one here. You get. Now because it said decreasing order. So this one is going to be the highest, followed towards this, then this, then this. You understand? So it will be 2, 4, 6 nitrophenol is greater, is what? Is greater than 2 nitrophenol. Do you understand? Then follow to what? Is greater than what? 3 nitrophenol. Greater than what? Phenol. That is it. So from the highest to the lowest is what is decreasing order. So I believe you have enjoyed this video. We are going to stop. We have to stop here. But we still have, we still have so many questions to answer based on this what topic here. So in next video we are going to look at what the strengths of base. If this video is helpful, please leave a comment at the comment section and say this video is helpful. I need more of this video that will help you understand chemistry faster and well better. If you are not subscribed to the channel, please hit that subscribe button and turn on the notification bell because you don't want to miss out every single content we drop that will help you pass your chemistry in a flying color. If you have any question, you can leave it at the comment section. Thanks for watching. See you in the next video.